Imagine you just hired like the most brilliantly well-read intern in human history. I mean, this person has consumed every book, every article, every single piece of code ever written.
Sounds like a great hire, honestly.
Right. But there is a catch, and it's a pretty massive one. This intern physically cannot say the words, I don't know.
Ah, yeah, that's a problem.
It's a huge problem because when they hit a gap in their knowledge, they don't pause to ask for help. They just confidently invent a completely plausible sounding answer and state it to you as absolute fact.
Yeah, and that right there is basically the defining management challenge of our era.
Exactly, because we are all constantly surrounded by these tools now. But if you're like a lot of professionals right now, you probably feel like you're just drowning in a sea of acronyms.
Oh, for sure. You're sitting in a meeting and people are just throwing around terms like, LLMs and multimodal and context windows and AI agents,
Then it leaves you feeling like a total outsider, like a tourist who got dropped into a foreign country without a phrase book.
which is exactly the dynamic we are tackling in this deep dive today.
Yep. We are unpacking a phenomenal source manual called the AI Lexicon Foundations. It's produced by the Modern Business Architect AI Academy. And the whole mission of this document, and really our mission today, is to shift your mindset. We want to take you from being an overwhelmed AI tourist to an empowered architect.
Because the core thesis of this manual is surprisingly simple, honestly. The barrier to actually using AI effectively isn't the underlying math. It's not the coding. It is the vocabulary.
It's just the words we use.
Right. Once you swap out all that scattered, kind of hyped up tech jargon for a structured understanding of just a few key mechanisms, the entire subject just quietly rearranges itself.
The intimidation factor just completely vanishes.
Exactly. You start to see the machinery under the hood, and, once you see how the gears connect, you can actually start driving the car.
So let's open up the hood. Before we get to the flashy conversational agents you might be using to draft your emails every day, we really have to clear the air on the foundational architecture.
Right. The absolute basics.
Yeah, and I want to jump straight past the basic definitions of AI that everyone already knows and look at the engine itself, machine learning and neural networks.
Which is where a lot of the confusion actually starts.
Definitely. Because for decades, software was just hard-coded logic, right? Like, if X happens, do Y. But machine learning flipped that entirely.
Yeah, the manual really highlights this transition. We stopped writing the rules
Mm.
and instead started feeding the machine the data so it could find its own rules.
I love the analogy they use in the source material for this. It's like teaching a child to recognize a dog. You don't sit a toddler down and read them a dictionary definition of a dog, right? Like a carnivorous mammal with 4 legs.
Right, they wouldn't understand that anyway.
Exactly. You just point at 100 dogs, you say dog over and over until the pattern clicks in their head. That is machine learning. It's pattern detection.
And that transition from hard-coded rules to pattern detection is critical because you can't build a modern AI by writing billions of lines of if-then statements.
Right. The complexity of human language or image recognition makes that literally impossible.
Exactly. Instead, you build a structure capable of that pattern detection, and that structure is the neural network.
Okay, so I am stuck on this one specific media trope, though, because you constantly see headlines calling a neural network a digital brain.
Oh, yeah.
Are these systems actually reasoning like a human brain, or are we just, anthropomorphizing a bunch of code because it spits out a conversational answer?
We are absolutely anthropomorphizing it, and the lexicon explicitly shoots down that digital brain metaphor.
Good, because it feels misleading.
It is incredibly misleading. There's no actual thinking happening. There's no cognitive understanding, no consciousness. A neural network is really just a mathematical architecture built in layers.
So let's visualize that mechanism, because I think deep learning is another term that confuses people. If I'm trying to picture what deep learning actually means under the hood, I just keep imagining like a massive factory assembly line of filters.
That's a great way to look at it.
Right, so you pour raw data in at the top, say a photograph. And the first filter is incredibly basic, right? It just catches hard edges and contrasts in the pixels.
Yeah, just light and dark.
But then it passes that result to the next filter, which catches geometric shapes, and then the next one catches textures.
Right, getting a little more complex each time.
Exactly. By the time this data passes through dozens or even hundreds of these stacked layers, which, by the way, is what makes the network deep, the final filter just spits out a highly confident label like, this is a picture of a golden retriever.
That is a remarkably accurate way to picture it. Each layer of the network is just a mathematical function extracting slightly more complex features than the layer right before it.
So it's entirely mechanical.
Completely mechanical. And when that complex multi-layered training process is finally finished, the resulting system is what we call a model.
A model. Okay.
Right? The model is the actual, finalized artifact that you deploy to do the work.
Which brings us to the shift that caused the current explosion in the tech world. Because for a long time, we used these models mostly to just sort things, right?
Yeah, classification.
Like an email comes in, the model filters its features and categorizes it as spam or not spam. But now we are in the era of generative AI. We aren't just sorting the inbox anymore. The model is actually writing the reply.
And the engine driving almost all of that generation is the large language model, or LLM.
The famous LLM.
Right. And the underlying mechanism of an LLM is, on paper at least, shockingly simple. It is trained on vast amounts of text to do one single thing, just predict the next token.
And a token being, what, a fragment of text? Like a word or even just a syllable?
Yes, exactly. It looks at the sequence of tokens you just gave it, calculates the statistical probability of what should logically come next, and then it generates it.
Just guessing the next token.
Right. And then it looks at that new sequence and predicts the next one. And it does this over and over and over again.
Okay, I have to push back here, because this is where the theory and the reality seem to totally collide for me.
How so?
Well, if all of this model is doing is playing a massive game of autocomplete-like, literally just guessing the next most likely syllable, how on earth is it writing a coherent 5-year go-to-market strategy for my business?
Yeah, it sounds impossible, right?
It does, because my phone's autocomplete suggests the word pizza when I type I want to eat. It doesn't formulate profound corporate logic, you know?
It's honestly the most common point of confusion for professionals who are adapting to this tech. The manual actually issues a specific warning about this exact cognitive dissonance.
Oh, really?
Yeah. Predicting tokens is indeed the raw mechanism. But when you scale that mechanism up to billions of parameters across an incredibly deep neural network, something fascinating emerges.
Okay, I'm listening.
To accurately predict the next word in a highly complex sentence, the model fundamentally has to learn the underlying rules of syntax, logic, and context.
Oh, I see. So it's not just memorizing set phrases, it's mapping the actual relationships between concepts.
Exactly. If it wants to successfully predict the next word in a complicated paragraph about macroeconomics, it mathematically has to understand how inflation relates to interest rates. Otherwise, its prediction will just be wrong.
So it builds a, what did the manual call it? A high-dimensional mathematical map of human knowledge.
Yes. Words essentially become vectors. They are coordinates on that map.
So when you ask it for a business strategy, it isn't actually thinking about your business. It is navigating that mathematical map, plotting a trajectory through concepts that human beings have historically linked together.
Precisely. Logic and reasoning essentially emerge as a byproduct of the system, trying to minimize prediction errors.
That is just wild. It's mapping the geography of human thought.
And it's not just text anymore either. The manual introduces multimodal AI, which takes that exact same predictive engine and equips it with more senses.
Senses.
Right.
This is where the utility absolutely skyrockets for a business architect. Because multimodal means the model can process multiple modes of input simultaneously, like text, obviously, but also images, audio, video.
Right. Going back to your intern analogy earlier, it's like taking that brilliant text-obsessed intern and finally giving them a pair of eyes.
Exactly. I don't have to spend 20 minutes describing a complex financial chart in an email to them anymore. I can just slide the visual chart across the desk, and they can process the pixels the exact same way they process syllables.
Because under the hood, the multimodal architecture breaks that image down into patches, turns those patches into tokens, and maps them onto that exact same mathematical geography.
So it treats visual patterns and linguistic patterns as part of just one single unified landscape.
It really does.
Okay, so we have this incredibly capable multimodal engine mapping the universe of data. But let's talk about the economics for a second. Because if training this system requires processing billions of tokens and mapping every concept in human history, the computing power must be just astronomical.
Oh, it's staggering.
So how are companies actually affording to let us use this every single day for like $20 a month?
They do it by splitting the life cycle of the AI into two totally distinct phases, training and inference. And this distinction is really crucial for understanding why AI products are priced and constrained the way they are.
Okay, so break those down. Training is the first phase.
Right. Training is the initial phase.
Huh?
It is an unimaginably massive, computationally brute force process. The tech giants spend tens, sometimes hundreds of millions of dollars on specialized hardware just to run this phase once.
I see. So it's basically like a surgeon's decade in medical school. The training is grueling, it takes years, it requires massive amounts of data, and it costs an absolute fortune.
Yeah, that's a perfect analogy.
Yeah.
But you only do it once.
Right.
And once that training is done, you have a finalized model. The weights and parameters are set. And that leads to the second phase, which is inference.
Inference, meaning when I actually use it.
Exactly. Inference is what happens when you query the model. When you hit send on your prompt, the model just runs your data through its layers and infers an output.
So inference is my 10-minute appointment with that highly trained surgeon. The years of incredibly expensive study are already baked in. I'm not paying for them to go to medical school while I sit in the waiting room. I'm just paying the negligible cost of a quick consultation.
Which is exactly why inference is fast, cheap, and easily repeatable on a massive scale.
But it's not totally free. When I build software using these models, I'm typically billed by the token, which honestly feels very retro.
Retro how?
It's like sending an old-fashioned telegram where you get charged by the word. Every syllable I send in and every syllable it generates back costs a fraction of a cent.
That's true. The financial cost is one limitation of tokens. But the more profound limitation for a user, the one that really affects your daily work, is memory. Because tokens dictate your context window.
The context window. This is basically the working memory of the AI for our specific active conversation, right?
That's right. The training data, the medical school from your analogy, is permanently baked into the model. But the context window is the immediate desk space the model has available for your current task.
Desk space, I like that.
Yeah, it's a hard limit on how many tokens it can hold in its active memory at one time. If you upload a massive PDF that exceeds that token limit, the model literally cannot see the whole document at once. Its desk is too small.
Oh man, this explains a major frustration I've had because sometimes I'm in a long, ongoing chat session, brainstorming ideas back and forth, and suddenly the AI just seems to get amnesia.
Yep, it drops things.
It completely drops a critical constraint I gave it like an hour ago. Is it just cleanly lopping off my oldest messages as new ones push them out the back door?
Not exactly. The lexicon clarifies that modern enterprise tools try to be much smarter about managing a full context window than just doing a hard cutoff.
Okay, so what do they do?
Rather than just dropping the oldest text, the system might quietly run a secondary process to compress the oldest parts of your conversation into a short summary. Or it might use vector search to only retrieve the specific past messages that seem mathematically relevant to your newest prompt.
Ah, so it's frantically trying to keep the desk organized. But in the process of compressing or filtering, it might accidentally toss out a highly specific nuance I mentioned earlier.
Precisely. It's just a side effect of managing limited working memory. Because what falls outside the context window, or what gets lost in that compression, effectively ceases to exist for the model.
So as an architect, someone who understands this machinery now, how do I actually steer this machine? If I know how it processes tokens and manages its desk space, how do I get high-quality work out of it?
Well, the manual boils this down to two everyday concepts that you have to master: prompt and context.
Right, and the prompt is simply your direct instruction, like draft a response to this angry client.
Sure, but a naked prompt is dangerous. If you just say draft a response, you're treating the AI like a vending machine.
Yeah, and I'm going to get a generic, overly formal, highly sanitized corporate apology back, which is useless.
Because you didn't provide any context. Context is the surrounding background information that constrains the mathematical map the AI is navigating. It's the client's history, it's your company's tone of voice, it's the specific resolution you are actually authorized to offer.
It's identical to briefing a human freelancer.
Completely.
Because if I hand a designer a really vague brief, if I just say, make me a logo, I get a bland template. If I give them a rich brief detailing the target audience, the brand ethos, and visual references, I get a tailored masterpiece.
Right.
And when the output improves, the freelancer didn't suddenly gain 20 IQ points. My brief just got better. The exact same rule applies to navigating an LLM. You have to narrow the parameters.
You do. But this introduces the most critical warning in the entire lexicon. What happens when your context is incomplete and the model simply does not know the answer?
Ah, hallucinations.
Yes. Hallucination is when a model states something entirely false, but it presents it to you with absolute, unwavering confidence.
It's so frustrating. It will invent a legal precedent or fabricate a historical date or hallucinate a financial metric, and it uses the exact same authoritative tone it uses for verified facts.
This goes right back to your intern who can't say, "I don't know."
Right. But why does it do this? Is it a glitch? Like, is it actively lying to me, or is it a bug in the code?
It isn't a bug at all. It
Yeah.
is the system functioning exactly as designed.
Wait, really?
Yeah. Remember the mechanism we discussed earlier? The model's fundamental mathematical imperative is to generate the most probable next token.
Okay.
It does not have an internal lie detector. It doesn't have a database of truth that it checks against. It only has statistical plausibility. So when it hits a void in its map, it doesn't gracefully stop and admit it doesn't know. The math forces it to bridge the gap with whatever tokens statistically sound the most plausible in that sentence.
So it's prioritizing fluency over accuracy. Sounding coherent is mathematically easier for it than verifying reality.
Exactly, which is why the manual lays down a golden rule for the AI architect. Trust the draft, verify the facts.
That's the draft, verify the facts. I like that.
You leverage the model for its astonishing speed, its ability to synthesize, its linguistic fluency, but you never, ever trust it as an unverified database for numbers, names, or high-stakes claims.
Okay, but if hallucination is a baked-in feature of the math, how do we fix it systematically in an enterprise setting? I mean, I can't be manually fact-checking every single sentence a customer service bot generates. I'd never sleep.
Right, that defeats the purpose. So the manual pivots here to a structural solution called grounding.
Grounding.
Grounding is how you turn a fluent AI into a trustworthy AI. Instead of letting the model freely navigate its massive, hazy map of internet training data, you force it to anchor its answers to a specific verified dataset that you provide inside the context window.
Oh, so it's essentially an open book exam.
That's a great way to think of it.
Yeah, because if I ask a student a highly technical question, they might panic and guess. But if I drop a verified textbook on their desk and say, answer my question using only the information in Chapter 4, the hallucination rate plummets.
Exactly.
They are still using their reading comprehension skills, but the facts are tethered to the text directly in front of them.
And that is exactly what grounding does in practice. You connect the LLM to your company's live policy documents or your real-time inventory databases. The model's instructions are fundamentally shifted from predict a plausible answer to extract the answer from this grounded source material.
Amazing. So we've given our intern eyes with multimodal capabilities, we've learned how to brief them with rich context, and we've cured their hallucination problem by grounding them with an open book exam.
We're building a pretty competent system here.
We really are. But now, how do we actually unleash them to do work rather than just chat with us? Because this is where we cross the line from tools into workflows and agents.
Yeah, and it's really important to separate those terms because they represent entirely different levels of autonomy. Automation and workflows are highly structured. Automation is just a machine running a set sequence.
Like a vending machine. You press a button, you get a snack.
Right. A customer submits a form, the software routes it to a folder, and pings a Slack channel. Press a button, get an outcome.
So the workflow is the defined, unbending recipe. But the entire tech world is currently obsessed with agents. What elevates a grounded LLM into an agent?
Goal-oriented autonomy. That's the difference. An agent doesn't follow a rigid recipe. You give the agent an objective like research our top 5 competitors' pricing changes over the last quarter and compile a brief.
But you don't tell it the steps.
Exactly. You don't tell it how to do it. The agent uses an underlying LLM as a reasoning engine to break that goal into steps on its own.
Oh, wow.
It decides to use a search tool. It reads the results. It realizes it needs to dig deeper on one specific competitor, runs a second search, and then formats the final document.
It's iterating. It's observing the results of its own actions and adjusting its path dynamically. But I have to challenge the hype here, because the way some vendors sell this, it sounds, quite frankly, terrifying.
It does sound like a sci-fi movie sometimes.
Yeah. If an agent has the freedom to make its own decisions and iterate, is it just roaming around my company's servers, opening files, sending external emails, and doing whatever it deems mathematically optimal, totally unsupervised?
And this is where the manual provides a massive, much-needed reality check, because the hype dramatically outpaces the current enterprise reality. Agents do not roam free. They operate strictly inside what we call a fence.
A fence, like a fence of permission.
Exactly. The architect builds the fence. You define precisely which tools the agent has access to. Maybe it has read-only access to a specific database, but it absolutely cannot write data or trigger emails without a human clicking approve. You constrain its environment.
So it's a spectrum of judgment. If a task never requires any judgment, I don't use an agent at all. I just use cheap, predictable automation. But if the task requires micro decisions and adaptability along the way, I deploy an agent, but I keep it inside a heavily monitored paddock. The human being remains fundamentally responsible for the outcome.
The agent acts, but the human oversees. That's the core dynamic.
Let's step back and look at the territory we've just covered. We started this deep dive feeling like AI tourists, just overwhelmed by all these acronyms. But look at the architecture we've unpacked.
It's a lot clearer now, isn't it?
It really is. We understand that the neural network isn't a digital brain. It's stacked mathematical layers acting as filters. We know the LLM engine generates logic simply by predicting tokens across a vast vector space.
Right.
We know how to manage its limited context window.
Right.
We know we have to ground it to prevent hallucinations, and we know how to deploy it as an agent strictly inside a secure fence. We aren't tourists anymore. We can actually see the blueprint.
And seeing that blueprint reveals a really profound insight about where the future of our work is actually heading. We spend an enormous amount of time as a society worrying that these models are going to entirely replace human intelligence. We fear obsolescence.
Yeah, that's the underlying anxiety in every industry right now.
But when you look closely at the architecture we just laid out, the absolute necessity for rich context, the requirement of grounded facts, the indispensable need for a permissions fence, you realize that the most crucial component of an AI's success is actually its limitations.
Because its mathematical limitations create a vacuum that only a human can fill, it requires us to map its capabilities to real-world business logic.
Exactly. In a strange paradox, the very flaws of artificial intelligence, its lack of intrinsic truth, its lack of worldly context, are exactly what make the critical thinking and strategic oversight of the human architect utterly irreplaceable.
Wow. But that raises a fascinating and maybe slightly provocative final thought for you to chew on. If our primary value right now is acting as the architect, the one who builds the fence, provides the grounded context, and oversees the agent, what happens in 3 or 4 years when these models become capable of generating their own context?
Right.
What happens when they learn to autonomously adjust their own fences based on the environmental feedback they receive? Are we cementing our roles as indispensable managers of this technology, or are we just temporarily training our replacements on how to build the very architecture that will ultimately run without us?
That is the multi-trillion-dollar question right there.
It absolutely is. Well, thank you for joining us on this deep dive. Our challenge to you today: don't just put this phrasebook back on the shelf. Open up your model of choice, give it a naked, terrible prompt, and watch it fail. Then rewrite that exact same prompt, but load the context window with rich, grounded constraints. Experience that architectural difference firsthand. We'll see you next time.